This is the execution for first come first serve algorithm. The output will show in FCFS output text file. The text file shows the average waiting time, turnaround time, and number of interrupts for first come first serve algorithm.
So I'm here to present the coding for shortest job next algorithm. So shortest job next function. So this is the calculation for completion time, calculation for total waiting time, total turnaround time, and total completion time or service time. This is the output that will be put in the file, which is text file. So I'm going to execute this coding. It shows that shortest job next is at number 2, so we press 2 and enter, and we will wait for the process. It says that the output will be in a file named sjn output text file. So we open it. It is organized according to process, arrival, burst time, waiting time, and turnaround time. So through this, we can know the number of processes, the total waiting time, total turnaround time, the average waiting time, the average turnaround time, and average interrupt. So this is all for the coding for shortest job next algorithm.
Hi, now I will show the program for the shortest remaining time. Okay, it is the part for shortest remaining time. I will show to you. This is okay here. Okay, now we run it. Okay, for shortest remaining time, we wait. Okay, the output is a file name SRT output dot text. Okay. Okay, here is the output.
This is the execution for round-robin algorithm. The output will show in RR output text. The result will show the average of waiting time, turnaround time, and number of interrupts for round-robin algorithm.
About average waiting time of 4 algorithms, which is first come first serve, shortest job next, shortest remaining time, and round robin algorithm. The graph shows that first come first serve is the highest average waiting time, followed by round robin, shortest job next, and shortest remaining time algorithm. So proceed to explanation. Based on the figure 1, first come first serve algorithm has the highest average waiting time compared to other algorithms, which is 18493.7 milliseconds. This shows that first come first serve is not an optimal average waiting time. The short processes that are at the back of the queue have to wait for the long processes to be finished. This algorithm has poor performance as the general wait time is quite high. Round-robin algorithm is the second highest of average waiting time, which is 13815.5 milliseconds. Round-robin algorithm performance is heavily depends on the size of the quantum. If the time quantum is large, the round-robin algorithm is similar to first-come first-serve algorithm. For this algorithm, the time quantum that are used is 10 CPU cycles. This algorithm also does not give any special priority to the important jobs and spends more time in context switching. The third highest average waiting time is shortest job next, which is 12390.5 milliseconds. Shortest job next prioritizes short processes more than long processes. Hence, this algorithm can decrease the waiting time. Consequently, average waiting time reduces. Overall, shortest job next algorithm is probably optimal as it gives minimum average waiting time for a given set of processes. Shortest remaining time algorithm. It has the lowest average waiting time compared to other algorithms, which is 1 to 3 at 0.0 milliseconds. Shortest remaining time algorithm is a preemptive version of shortest job next algorithm. This algorithm is very good because the short processes handle quickly. Little overhead is required since it only decides when a process completes or a new process is added. As a new process added, the algorithm will compare the new process with the current process, ignoring all other processes currently waiting to execute. Compared to shortest job next algorithm, shortest remaining time algorithm makes the processing of the jobs faster. In short, for average time category, the best algorithm is shortest remaining time because it has the most minimum value of average waiting time compared to first come first serve, shortest job next, and round robin algorithm. Thank you.
The turnaround time is one of the main criteria to determine the high quality CPU scheduling algorithm. Okay, based on the graph 2, first come first serve algorithm has the highest average turnaround time compared to another algorithm with average 90,504.2, 6.1. The lowest average turnaround time based on the graph is shortest remaining time with average 12,390.5. Okay, based on the data from the graph, first come first serve is the highest average turnaround time, which is did not have a good turnaround time. A long process at the beginning, because the short process have to wait until the long process end before it begin to process. Okay, for the second highest, which is shortest job next algorithm, the job it let the shortest job do the process first. So the algorithm may cause a long turnaround time and it leads to a starvation that does not reduce average turnaround time. For round robin, which is the third highest average turnaround time, it's allow each process is provided a fixed time to execute. It's called a quantum, which is 10 CPU cycle in this project. Since it have a large CPU cycle, it reduces the turnaround time. Okay, for the lowest average turnaround time, which is shortest remaining time, it process the shortest execute time. This increase job output by offering shorter job which must be executed first, most which have a shorter turnaround time. So in conclusion, shortest remaining time is the best process scheduling algorithm in terms of turnaround time compared to another because it have a lowest average turnaround time. Thank you.
Processor. The context switch can also occur as the result of an interrupt. The context switch is frequently occur because every upcoming job, if selected for execution, can cause a context switch even though it is slightly shorter than the currently running job. Possibility to get interrupt overload is high because interrupt is given higher priority than other tasks. Since SJN is non-preemptive algorithm, the I/O bound job will not interrupt a job running processor in the middle of execution. Since the context switch does not happen in the SJN, the possibility to get interrupt overload is low. I will present the recommend algorithm for listed job for Unimas web. The suitable algorithm for supplies job listed is we recommend round robin algorithm. The graph show all data for round robin algorithm. We choose round robin algorithm because it normalizes the turnaround time for all jobs since the algorithm treat all job failure. This algorithm also better at adjusting the average waiting time because this algorithm use time content for both CPU and I/O value. Besides that, round-robin algorithm is better working in multiple jobs where it's designed especially for time-sharing system. No starvation will occur when use this algorithm and give the result to proper response time. Lastly, since each time content bring a context switch, therefore the possibility to occur overhead is low.